Okay, so we can start. Good evening, everyone. My name is Abhishek. I am a PMRF research scholar from IIT Guwahati. So, I wish everyone a happy Independence Day. And what we'll be doing is this is a week. This is the live interactive session for week one, and we'll be covering a few questions. Question that was pertaining to this week. And first of all, what I have done is I have divided the whole session into first we'll be doing some. I will be going through the summary of the lectures that were covered. So this week only there were two lectures. So based on that, I have made some summary slides. So just you can remember if if you have forgotten something, then we can directly jump into question. As this was an introductory session, so there will be only multiple choice questions. Multiple choice questions, and maybe in the other sessions we will be having some numericals. Okay, so let's start. So my voice is clearly audible, my screen is visible, everything is fine. Someone can confirm. Am I audible?
Yes, sir.
Okay, thank you. So we'll start with the lecture 1. So if you see, the lecture 1 was about external and internal combustion engine components and SI engine. Mostly if you see this was the introductory session, so it all started with what is an engine. So if someone want to take part in the discussion, can tell what is an engine. Kindly unmute your mic, and if you want to say, just say it. We'll make the session as interactive as possible. Okay, just say what is an engine, what is the definition of an engine. So I'll wait for another 5 seconds. Okay, so engine is any device which converts one form of energy into other form of energy. Okay, so for example, in an engine there might be conversion of one form of energy. Let us say it can be chemical energy. It might be getting converted into mechanical energy. Okay, this is what generally takes place. Then what is an external and internal combustion engine? Now that is the basic difference that we have to see is, in any engine, as I said, there is a conversion of energy from one form to the other form. So generally what happens is, if you see, there is a combustion. So what happens in a combustion? A fuel is ignited or it is combusted. So the chemical energy, the calorific value that we have, it is we get it through a thermal energy. We get that thermal energy is converted into mechanical energy. That is what happens in most of the engines. Okay. So if we go for external engine, what is the major difference between an external engine and an internal engine is that an external engine, the combustion takes place outside the combustion chamber, or let us say outside the engine. So if there is a combustion outside the engine, then how this heat transfer is, this thermal energy is transported to the position where the energy that we get back in form of mechanical energy. That is how it is done in external engine. What we do is we ignite the fuel. The thermal energy that is being generated, what we do is we transfer the heat through a heat transfer fluid, and we run around the walls of the engine, walls of the combustion chamber. Okay, so you can find it in any steam turbine, because in steam turbine, if you see in a steam power plant, what we do is we combust the coal, and that energy we transfer it through a steam, and that steam is used to run the turbine. Okay, so that is generally the external combustion engine. In an internal combustion engine, which is our main interest in this course, so it is where there is a chamber, or we can say it is an engine or a combustion chamber. The combustion takes place inside this chamber, and all the processes like the power generation or the expansion, whatever the cycle, there are few steps that is in a particular cycle. This is done in a combustion chamber. Everything takes place in a single chamber, and that is why we call it as internal combustion, because the combustion takes place inside is a combustion chamber. Okay, so after that, if we see what the next thing was covered was what are the important components of the IC engine. So basically there are many parts. but some of the parts that I have mentioned is carburetor, spark plug, and piston ring. So if you see, what is the function of a carburetor? If you see, is it present in all the engines? So carburetor is generally present in a SI engine. Now what is an SI engine? It is a self ignition engine, okay, or a spark ignition engine, okay. So in spark ignition engine, what we do is we ignite the fuel by using a spark. We have a spark plug which gives the particular amount of energy to that of the fuel, and that fuel is combusted, okay. Now what is the function of a piston ring? That will be covering in the further. There is one question that will be covering, so that will be understanding, okay. Then next is the classification of IC engine. The next thing that we covered was the IC engine. So there can be many ways of classifying this IC engine, but majorly what we have covered is the type of combustion and the number of stroke. In type of combustion, it can be called a spark ignition engine or a compression ignition engine, okay. In spark ignition engine, what we told is we ignite by giving a flame to the fuel, okay, and that is done through the spark plug. This is what happens in a spark ignition engine, and the fuel that is used is petrol. But in case of compression ignition engine, that is done through the fuel that is used is diesel, okay. So what is why there is a spark plug in a spark ignition engine and there is no spark plug in a compression ignition engine lies in the fact that what fuel it is used. So petrol has is an ignition temperature of around 280 degrees Celsius, okay. So and diesel is a little bit lesser than that, okay, less than 280 degrees Celsius. So what happens is, in diesel engine we actually provide the air, only air into the chamber, and we compress it, and we increase the temperature of the temperature inside the engine, and the temperature is so high that whenever the fuel is sprayed into the chamber, the fuel gets ignited. But in petrol engine, by compression we cannot reach till this much temperature. So what we do is we provide a flame, and that flame is enough to ignite the petrol. That is what is the basic difference between spark ignition engine and compression ignition engine. Now comes the based on the number of strokes. So what is a stroke? Before that, we'll be covering what is the stroke. Now stroke is the volume, or let us say the length, that the piston covers from the top dead center to the bottom dead center, or vice versa, okay. So it is the length that the piston covers from the top dead center to the bottom dead center, or the opposite, okay. So the whole cycle, if it is whole cycle of generating power, if it is done in two strokes, then it is a two-stroke engine. And if it is done in 4-stroke, then it is a 4-stroke engine, okay. Now what are the different strokes we'll be covering in the next slide. Before that, what is the basic difference between the SI engine and the CI engine, we have mentioned in this table. So based on the basic cycle, what is the cycle that is used is Otto cycle in SI engine, that is the petrol is used, and another is the diesel cycle. This is the in case of CI engine. Now the introduction of the fuel that I said, in an SI engine, generally what we do is we already in the combustion chamber we already have fuel and air, and this is what is sprayed using a carburetor, okay. Now carburetor is used to spray the mixture of fuel and air, and that is used, and that is ignited by a spark plug, that I have already covered. And then comes the SI engine. In SI engine, the fuel is not sprayed initially. What is done is, first air is is sucked inside the sucked inside the cylinder. Now this air is compressed, and the temperature, at a particular temperature, the fuel is sprayed, and then it catches fire, and there is a combustion. And if case how this combustion takes place, I have already covered. That is the SI engine is the spark plug is used, whereas in diesel cycle, what we do is we have high pressure and high temperature. We compress that air, and the temperature that is that we reach is enough to ignite the fire. Okay, and the compression ratio that we see is generally it is lesser in SI engine. We get around 5 to 10.5, and it's around 12 to 20 in case of CI engine. Okay, so we'll go to the next slide. So this was the lecture 2. In lecture 2, the general functioning of a 4-stroke and 2-stroke was covered. So I will be covering what are the strokes briefly. So in a 4-stroke, as I covered, there will be the total cycle will be done using 4 different strokes. Okay, so the first stroke is when, let us say, the piston is the top dead center and this is the bottom dead center. I hope it is visible. This is top dead center, this is bottom dead center, and this is top dead center. Okay, so what happens is, just imagine initially both the valves are closed now. Okay, so once now let's start the first stroke. The first stroke will be intake stroke. This intake stroke is also called as suction stroke. Now what will be done is, we'll be opening the intake stroke. Intake stroke will open and this piston will come down. As we know, it is coming down means volume is increasing. Volume that the gas can acquire is increasing. So as the volume increases, pressure reduces. So there will be a point at the bottom dead center where the pressure inside will be less than atmospheric pressure, and this is the point where the air or the fuel air mixture pushes inside the cylinder. Okay, the exhaust port or exhaust valve is closed now. Now this is the suction stroke. Now all the fuel, or the, let us say, the charge is already inside the cylinder. Now the valve will close. This is closed, this was already closed. Now there will be compression. Now what compression will do, already there are gases inside this, gases or the air plus gas mixture is inside this. Now the piston will move up. It will move from bottom dead center to the top dead center. Now as it moves, we can see there is reduction in volume, so there will be increase in pressure, and thus there will be increase in temperature. So let us say if there is some X amount of temperature here, but when at the end of this compression stroke, the temperature will be 3x or 4x. That will depend on the operating cycle. Okay, once that temperature is reached, now what will be done is, still these two valves are closed, there will be ignition. This is a spark ignition. There will be ignition which will be igniting this fuel. Okay, this charge, and thus there is a huge amount of energy that is as the fuel gas combusted, there is a huge amount of energy that is released, and that generates a thrust to the piston, and the piston again comes down in the third stroke. Okay, this is expansion stroke. So thus pressure will reduce and there will be expansion. This is the power stroke, because as this piston is coming down, it is not coming down by itself, it is coming due to the combustion of the fuel. So we are getting the power as this is connected to the crank, and thus will get work through this. Okay, this is the power stroke. Then comes the exhaust stroke. Now once the power is generated, now the fuel is already combusted, there is only combusted products are present in this gas. Okay, so now it will move from BDC to TDC, and thus this valve inlet was closed, outlet will open at a particular pressure. Let us say it reaches here and the pressure is, let us say, P1. So it will be so maintained that at P1 pressure this valve will open, and once this valve opens, the combusted products moves out. So this is the whole cycle of a four different strokes in a 4-stroke engine. But in 2-stroke, see, the total cycle will be done in four different processes. That is, first is suction, then is compression, then is expansion, then is exhaust. So this will be done in a two-stroke engine also, but the only difference is that the piston will be covering from top dead center to bottom dead center twice in one cycle. Okay, so how it is done, just I will show you here. So let us say it will start with the power stroke. Now what is the power stroke that I have already said here is that the ignition has already taken place and the piston is here. Let us say the piston is here and the ignition has already taken place. So there will be a large amount of energy that will be released, and this energy or this power is enough to push the piston downwards. Now as the piston comes downwards, it moves the crank. As this crank moves, the fuel is already present here in the crankcase. This will be compressed because this is coming down. So this will compress the fuel, or it will compress the charge. Okay. Now as it comes down, this has already, the gases has already ignited. So this combusted gases has to be moved out. So as it comes down below this exhaust port, all the combusted gases moves out. Okay. And again, when it comes below the transport port, the compressed gas moves through the transport port and it goes to the cylinder head. Okay, so a certain amount of compression has already taken place. It moves through the transport port and it goes there. Okay, so in this stroke, what is taking place? There is compression and there is also exhaust. Okay, then what happens is, as the this compressed gas moves this side, moves to the cylinder head, what will be happening is the rest combusted gases are pushed by the fresh compressed charge to compressed charge. Okay, now this port will open. This is the inlet port. Now as this inlet port opens, it will be it will be getting filled in this space, and this will be pushing the piston upwards, and thus there will be compression. So there will be some temperature rise, and then there will be rise in the temperature, and thus there will be ignition. This is what is a two-stroke engine. The basic difference that you can find is that in a four-stroke there will be valves that will be present, but in two-stroke generally there are ports: exhaust port, transfer port, and the inlet port. Okay, there are no valves. Okay, so this is the summary of the things that were covered in the lectures. So we'll go to the question directly now. So everyone is following, right? Actually I cannot see you, so I hope everyone is following. So let's start with the first question. So I hope if everyone can take part in the discussion, then it will be very nice. So let's start with the first question: the function of the piston rings. Someone wants to say
cylinder.
Someone wants to say something.
Seal the cylinder, sir. Option C.
Okay.
Prevent piston
else?
for wear.
Okay. I understood. Just I will wait for someone else to respond. So anyone else want to point out what is the answer to this question? Okay, we'll wait for some 5 seconds. 5, 4, 3, 2, 1. Okay, so he said seal the cylinder. Sorry, anyone wants to answer?
Option A.
Okay, so let's start. I will explain this concept, then I think you will get the answer. So let us say this is the cylinder and this is the piston. Okay, and what will be there is, there will be small grooves around these cylinders, around these pistons. Okay, now in these grooves there will be piston rings, just like our pressure cooker. You might have seen the lid of the pressure cooker has a rubber like structure which seals the chamber, okay, so that the pressure inside the pressure cooker can rise. Okay, something similar function is that of a cylinder, or is that of a piston ring. Okay, so one of the function that I already said is that the piston rings will be making a gas tight joint. No gas can escape, the combustion gas cannot escape through this piston. It cannot come towards this side, it cannot come. So one of the thing is it will seal the cylinder. Okay, then prevent the piston from the wear. Okay, this is also the right answer, because if you see, the piston is a aluminium, generally it is made of aluminium, and this is cast iron. Okay, so when there will be repeated motion of the piston coming from top dead center to the bottom dead center, there will be wear and tear, and we don't want the piston to get damaged. Okay, because this is very important component of the engine, so we don't want the piston to get damaged. So we have a piston rings which will prevent the piston from wear. So this is also right answer. Then dissipate heat to the cylinder walls, and this is very obvious, because if you have seen your I think everyone might know how to ride the bikes. So in a bike you might have seen the engine has fins. Now why this fin is there? Because the temperature inside the chamber is very huge, so this needs to be cooled down. This is cooled by, this is air cooled. The fin is used to cool down. Now how this cools down is that through this piston rings, because the piston gets heated, so it will transfer the thermal energy through the piston rings. Okay, so one answer is also dissipate the heat to the cylinder walls, so that the thermal energy is adjusted outside through the fin. Okay, so the final answer is all of the above. Okay, so we'll move to the next question. Okay, so if someone is not speaking, you can mute yourself. Okay, so we'll go to this question. The weight of the SI engine is relatively higher than that of a CI engine. This statement is
False.
please kindly
False, sir.
please
B.
kindly mute yourself. Someone who
B,
is
B, sir.
okay. Okay, someone has answered it is false. Okay, so anybody else? Someone wants to say true, because two answers are only possible. So someone wants to say true. Okay, so basically this question, what I want to show you, is incomplete, because it has not written in what condition. If you see, it is just a general statement. The weight of the SI engine is relatively higher than that of CI engine. In what scenario? Okay, that should be of same power. Okay, because if someone will say, if some SI engine is generating a power of, let us say, 90 kilowatt, okay, it will be higher than some engine which is around 20 kilowatt CI engine. Obviously that weight will be higher. So there needs to be a condition that is same power. When the same power is there, then the CI engine is heavier. Now why this is so? Just I will, I know many of you might be knowing the answer. Just I will briefly say. See, in CI engine you might have seen the compression ratio is high. The compression ratio is high. That means the pressure that will be achieved will be higher. So if pressure achieved will be higher, then this will lead to temperature will be higher. So we don't need any spark plug here. So as the pressure and temperature will be higher, so the cylinder walls, the wall thickness will be higher. Okay, so that is why the weight will be higher in case of CI engine of same power. Okay, so this is the thing. We'll go to the next question. So which of the following statement is or are true for the CI engine? Okay, so we'll read one by one statement. So carefully read and just understand. The fuel and the air are introduced into the chambers of CI engine as a gaseous mixture. Is this true?
No, sir.
No, sir.
Okay,
False.
correct. So it is not correct. Next statement is CI engine is based on the diesel cycle. Is this correct? This is correct.
Yes, sir. Correct.
Then the CI engine
Yes,
has
sir.
then
Yes, sir.
okay. The CI engine has a compression ratio between 12 to 20, which is correct.
Yes, sir. Correct.
Is spark plug
Yes,
necessary?
sir. Correct. Correct, sir.
Spark plug is necessary to initiate the combustion CI engine. Is this correct?
No, sir. D is wrong one.
False.
Correct. Correct. Very good. So
False.
No, sir.
So
False,
the
sir.
answer is B and C. Okay. So I think everything we have already covered. So we'll not go into details here. We'll move to the next question. What the compression ratio can be defined as: A. Clearance volume by swept volume. B. Clearance volume by plus swept volume by clearance volume. C. Swept volume by clearance volume. Or D. Clearance plus swept by swept.
Sir, option B.
Option B. Okay. Anybody else?
So a clearance volume by swept.
B, sir. Option B is the correct answer.
Okay. Other than B, anyone else has anything to say?
Option Option A. Clearance volume by swept volume.
Okay.
Sir, A option, clearance by swept.
Okay. So let's.
Option A.
Okay. You yourself will answer. Just I will explain you what is the how we calculate the compression ratio actually. So if we say this is the engine. So as I said, this is the top dead center. And as I said, the volume that is covered from the, this is the bottom dead center, this is the top dead center. So the volume that is covered from top dead center to the bottom dead center is the swept volume, and this is the clearance volume. What is clearance volume and why it is needed? Because there will be some valves or there will be spark plug which requires space. So we cannot totally make the piston to move from this end to that end. So there will be some clearance volume that we known as clearance volume. Okay. So the compression ratio is generally represented as the final pressure after compression, by the pressure before compression. Okay. So if we convert it into the volume, let us say, so the final volume after compression and final volume before compression. So what is the total volume of the gases or the air that the total air is occupying in the cylinder before compression? It is swept volume plus compression volume. Okay. Now what is the final volume that after compression, how much the charge is occupying? The piston will be at the top dead center. So the only volume that the gases are present are in the VC. That is the clearance volume. So option B is the right answer. Okay. I hope everyone understood. Everyone who had confusion between A and B. So I hope you might have understood this one.
Yeah.
Okay. So, and this is the another question. If an engine is classified as a two-stroke engine, then the number of working strokes per minute for a two-stroke cycle are 1/2 the speed of the engine in rounds per minute, twice the speed of engine in rounds per minute, equal the speed of the engine in rounds per minute, or 4 times the speed of engines in rounds per minute. Anybody wants to try this question?
Equal, sir.
Option B.
Option B, someone is saying option B and someone is saying option C. Okay. And anybody else?
Option C.
Okay. Other than B and C, anyone else has any?
Option C, sir.
Okay. Okay. So I think a majority of students are saying C. So if someone is thinking it to be B, then let me explain. So what happens in a two-stroke, as I covered? In two-stroke, that is there is one power stroke, or let us say that is working stroke, one power stroke in each revolution of the crank, in one revolution. So if we convert that into per minute, because we are talking about speed, so that is how that one power stroke is equal to the speed of the engine in rounds per minute, which is C. If the question would have been 4 stroke, then what would be the answer? It would have been half of the speed, because there will be one working stroke in 2 revolutions of the crank, or 4 strokes. Okay, so I hope the confusion is clear. So we'll move to next question. In 4 stroke in the SI engine, the pressure inside the combustion chamber during the suction stroke is below the atmospheric pressure, equal to atmospheric pressure, above the atmospheric pressure, none of the mentioned. So first read the question carefully, where it is asking the pressure inside the combustion chamber during suction stroke.
Sir, below the atmospheric pressure.
Okay.
Below the option A.
Okay.
Below the atmosphere pressure.
Correct.
Option A.
So I think everyone is clear. It is below the atmospheric pressure because we want the air to be sucked in inside the chamber. Okay. So we'll be moving to next question. Okay, this is a little bit tricky question. So because this thing will be covered in your next courses, because when there will be teaching of valve timing diagram. So, but let's see. Intake valve opens slightly dash, piston is at dash, and closes the slightly dash, and piston is at dash. So this is talking about suction, because intake, it is talking about intake valve. When does the intake valve opens? As I covered, it is generally in
Before.
suction stroke.
Before, sir. Before.
Okay, just
Before TDC.
okay, just I will explain everyone. So suction stroke, what happens in suction stroke is that, what is our main aim? If we go to the cylinder, what is our main aim? Our main aim is to occupy, or is to carry more and more amount of gas in a single cycle. Okay, more and more amount of volume of gas, more and more volume of the gas in a single cycle. And how that will be possible? If we somehow increase the stroke, if we somehow increase the amount of the volume of air intake, volume of air, or volume of the gas mixture, in one stroke, then we can increase the amount of the volume. Okay, so how that can be done? So when does the intake valve opens? It opens when the piston is at the top dead center. So if for example it will be opening before the top dead center, or it will be opening after the top dead center, then there will be some amount of reduction in the volume of the air that is taken in. Okay, so that is why it will open before the piston reaches the top dead center. Okay, before the piston reaches the top dead center, it will open, the intake will open, and it starts, the air starts, fresh air starts coming inside, then it will come down to bottom dead center. Okay, and when it comes down to bottom dead center, we want that the whole air should come till the end of this stroke. So there the valve will close slightly delayed after the piston has reached the bottom dead center. So the correct answer is before the top dead center, after the BDC. The answer is B. So if someone was telling B, he was correct, or C is correct. Okay, the next question is, which of the following statements are correct? The petrol occupies more space than the diesel for the same power output. So this one we have already covered. This is false or correct? This is false. Okay. Then the thermal efficiency of a 4-stroke engine is more than that of a thermal efficiency of a two-stroke engine. Is this correct or wrong?
It is correct.
This is correct. So if the intake air temperature increases, the efficiency of the IC engine will decrease. So I think you might not have covered this one. You will be covering it very soon. This process is generally called supercharging. You will be covering it very soon. Supercharging. What is supercharging? What we do is we generally provide pressurized gases, pressurized air into the cylinder. Pressurized air into the cylinder. Now, if that will do, if the pressurized air means density of the air will be higher, so that more amount of air can get inside that cylinder. So if density is more, temperature will be less. So this is done to generally enhance the efficiency. So if the temperature will be higher, of course the efficiency will reduce. So that is why this is correct. Then with the increase in the cutoff ratio of the thermal efficiency of the diesel cycle having fixed compression ratio will decrease. This is correct or wrong? Again, this thing you will be covering in the next classes where you will be analyzing the diesel engine and the Otto cycle. So what is happening is cutoff ratio. You will be reading there it is a particular amount of ratio which is the volume after the power stroke by volume before after the compression, V3 by V2. You will be covering this one. So if the cutoff ratio will increase, so the power that will be generated power will be higher. If cutoff ratio, if RC is higher, power is higher. So if power is higher, of course the efficiency will be higher. So this one is wrong. So the answer is B and C.
Sir, why option A is false, sir?
Option A is false because see, the petrol engine occupies more space than the diesel engine for the same power output. Because if you see the diesel engine, here the compression ratio that we have to achieve, is higher, but the same power output means if you are taking the same amount of fuel, then in one case we are reducing the inside volume, we have to increase the inside volume so that we can carry same amount of mass of fuel. So that is why generally if you see the diesel engine is bulkier, because the engine is little bit higher, larger in size, because more amount of fuel you have to carry inside. Okay, that is why the petrol engine will take lesser space than the diesel engine. Diesel engine are little bit bulkier and it are more larger. Okay, so we'll be moving towards the next question. The sequence of operation stages of a 4-stroke engine is. This is very easy. Just tell me directly.
Yes, sir.
Yeah, right. The answer
Option
is
D.
Yeah.
D1.
It is suction, compression, expansion, and exhaust. Okay. Then this is another question. During the suction stroke in petrol engine, the required proportion.
Carburetor, sir. Option C.
Correct. So nothing to explain here. We'll move to next. The intake charge in diesel engine consists of
Only air, sir.
correct.
Air alone.
Correct. So no need to explain here. So we'll move to next question. So the disadvantages of an reciprocating IC engine are: will there be vibration in IC engine? Of course there will be vibration because this is a reciprocating engine.
The box.
All of the above. Yeah, the right answer is all of the above. So I will just
All of them.
yeah. Reciprocating engine. So reciprocating means there is some physical movement or the mechanical motion. So this motion will generate vibration. So there will be vibration. There will the use of fossil fuel. Of course, there is a use of fossil fuel. Petrol or diesel are fossil fuels. Then the balancing problem. Yes, there are balancing problems. That is why you might be studying in your undergrad level that there is a thing called you might have studied in kinematics and dynamics of machine. There is we balance it by using a mass. counter mass to the crank. If you have studied, it's fine. If you have not studied, you will be studying it. So there is balancing problems. So the answer is all of the above. Then we'll cover, okay, just I will, because as the in 1 hour this link will expire. So I will just share you.
See, sir. See.
Okay, just wait. Just I will share you the updated link, because if there will, this is for just 1 hour. I'm sharing it in the chat box. Okay, we can people, you can join directly into this link, because only 12 minutes are left, so we'll join through the other link. Everyone kindly join the other link.
Sir, send me the link, sir.
Okay, just I'll share the link here also. Still people are here, kindly join the other link. Razi Burma, kindly. Razi Burma, Uday Kumar, are you there? Yeah, Binod Chopala, you want to say something, you will directly join that link. If someone has joined just now, just see the link, I've given it in the chat box. Still Ravi Verma, Vinod Chopala, Yashaswini. Kindly join the other. Still Ravi Verma. Janvi. Did you find the link, Janvi?
Sir.
Yeah, just join that other link. I have provided it in the chat box. Janvi? Ravi, are you there?
Hello?
Ravi, join this link. I have given it in the chat box.
Sir, I'm actually not getting the chat box. Where I can find it?
Okay, that is, you can find it. Have you joined through mobile or have you joined through laptop?
I'm joined through mobile, sir.
So mobile, you can find that three dots.
Where, sir?
So,
Sir, can you send me the link to my email ID, sir?
okay, just tell me your email ID.
Sir, it is RAVI.
Just wait, just wait. Yeah, tell me what is your mail ID?
RAVI. Ravi Verma, VERMA. Ravi Verma.
RAVIVERMA. Okay.
05
05
1063
1063
@gmail.com.
Okay, it's Ravi Verma 051063 @gmail.com, correct?
Yes. Yeah,
Okay.
that's right.
Okay, I have sent. Just join. Okay. Okay, I hope everyone has joined. Just Ravi will be joining in few minutes. We can start directly. Just I'll present the screen. Everyone is able to see my screen, right? Just I will share it. Okay, everyone is able to see.
Yeah, it is.
Option A.
Okay, so we'll start. Just some 10 seconds we'll wait. Then we'll start. Sorry for the interruption. We'll start. Okay, so we'll start now. So the question that we were handling was Gudgeon pin forms the link between the piston at the big end of the connecting rod, piston at the small end of the connecting rod and the crank, big end at the small end. Okay. So if someone wants to try it, then they can
Option
try.
B, sir.
Option A.
Okay. So there is some confusion. Oh, somebody has given some chat message. Okay, just I cannot see it, so I will just look into it. Okay. Okay. Okay, so what is a gudgeon pin? First we'll understand. Okay, so if you see, this is the engine, and as I said, this is the piston. There is a crank, or let us say this is a wheel, crank wheel there. Okay, then this is a center, or what do we call it? Is the crankshaft. This is called crankshaft. This is the shaft on which the crank rotates. Then there will be a crank. This will be a crank. This is a piston, so there will be a pin that will join this is called connecting rod. This is called connecting rod. Okay, this is called crank. And this is called, so there are two pins particularly, just I will change the color so that you can understand. So there are two pins, two important pins you should remember. One is a pin that attaches the piston and this connecting rod, and there is a pin that attaches this crank, this connecting rod with this. Okay, so this is called gudgeon pin. This is called gudgeon pin, and this is called crank pin. Okay, so now we are from this we got to know that okay, it is a pin that connects piston and a connecting rod. Whether that is small end or less, big end, we'll see that one. Just based on your common sense, just think. See, what do we want when a piston moves or piston does a reciprocating motion from TDC, from the BDC to the TDC? What do we want actually? We want as fast as possible the piston to move up. It should move up and down. There should be reciprocating motion as fast as possible. And how is this possible? When the inertia or the mass, inertia is less. Okay, when the inertia is less, then only this can move faster, because if there is more inertia, then more amount of energy is being used, and we cannot move our bulkier object very fast. So we have to move this piston as fast as possible. That is why majorly you have as I've already covered it, piston is made of aluminum, because we want it to be lighter. That is why the connecting rod small end will be connecting to the piston, and the large end or the bigger end will be connecting to the crank. Okay, so generally the piston, if you the connecting rod shape, I cannot draw here properly, you can see it just like this. This is the larger bigger end, and this will be the smaller end. Now this here heavier or the bigger end is there. Why this is so? Because so that you can move the crank easily, because this mass, if mass is higher, you can move the object around this crank easily. That is why the answer is piston and the small end of the connecting rod. Now you understood. If the question was crank pin, the answer would have been different. The answer would have been the big end and the connecting rod and the crank. Then their crank pin is used. Okay. Then we'll go to the next question. Engines of different cylinders, different cylinder dimensions, power and speed are compared on the basis of what? Maximum pressure, fuel consumption, mean effective pressure, or unit power. Which one?
Mean effective pressure.
Yeah, correct. It is mean effective pressure. You will be covering it in the next lecture, where you will be studying the design parameters of engine. Parameters. Several of the things you will be studying: brake power, indicated power. In that case, you will be finding a term called mean effective pressure. Okay. Now what is this mean effective pressure? Just I will explain it briefly. So generally, as I already said, so if there is an expansion cycle, generally the power we get is in the expansion stroke. Okay, let us say it is moving from 1 to 2. Okay, this is a diagram between P versus V. So the volume is increasing, pressure is reducing. So at each point the pressure is different. But when we have to design any engine, we have to consider a particular pressure. So that is what is a mean effective pressure. How do we assume it? So let us say it is mean effective pressure is PM. So the area under PV what do we get area under PV? In a closed cycle, what is the area under PV on volumes?
Work done.
Work done.
Correct. So this is work done. So we choose a particular pressure in such a way that this is the average, mean as it is written, so it is average pressure, which will also be through this when we'll multiply this PM with the swept volume, then we'll get the work. Okay, so this is that pressure. So this is generally what I will say, it's a theoretical concept. So this is the pressure at which will generate the same amount of work that is being generated in an expansion stroke. Okay, so through that only we decide, means we can compare to different engine. Okay. Then the next question, the volumetric efficiency of SI engine is sorry.
Sir, last question.
Okay, tell me.
We are taking mean pressure. Whose mean pressure, sir?
See,
Or it just a pressure which created in the
how it is
combustion?
No. I will tell you. Okay, so how it is calculated, I will show you. You will be studying it. Still, I am telling. It will be generally the work done by the swept volume. As you know, you might have studied that P del V is work. So through this only, this work, this mean effective pressure will be getting by P by swept volume. So this is nothing but just the mean pressure. Means, for example, if you multiply 10 into 5 is 50. But there may be several such pressure like P1. This small amount of pressure will have this much amount of work. Then this cumulative, when you integrate, will give the amount of work is same as that will be given by PM into delta V or Vs, swept volume. This is that pressure. Okay, did you get?
Okay, sir. Understood, sir. By integrating the area, we can get the mean effective pressure.
No, not by. Okay, that you will be covered. That will be covered in the next lecture. You will be clearly understanding that. Don't worry. Okay.
Okay, sir.
Okay, so the next question is, the volumetric efficiency of SI engine is comparatively lower than the CI engine, higher than the CI engine, will same as the CI engine, or none of the above?
Higher than the CI engine.
SI engines, what is the volumetric efficiency around? Any guesses? It is about 80%. Okay. But in CI engine it is around 85%. So the CI engine's volumetric efficiency is higher. Okay. Now what is volumetric efficiency? Does anyone? This is also one of the design parameter. You will be covering it in the next lecture. What is the volumetric efficiency? This is the actual rate of air that is being intaked. Actual volume or the rate of volume that is being intaked into the cylinder by the swept volume or the displaced volume. This is the volumetric efficiency. Okay. So generally you can remember it that the volume of SI engine is lower than the CI engine. Okay. So the next question. The thermal efficiency of a CI engine is higher than that of SI engine due to what? Is it due to the fuel used? Is it due to the compression ratio, or is it due to the constant pressure heat addition? Because you know that in CI engine the heat is added in constant pressure, but in SI engine it is added through constant volume. So what is the answer? The answer is higher compression ratio. The compression ratio of CI engine is higher. We have already covered that one. See, 12 to 20. Now why this is so much higher compression ratio? So that we can reach the temperature at which we can ignite diesel. That is why the compression ratio will be higher. And once the compression ratio is higher, the formula, that thermal efficiency formula, you will be studying very soon, 1 by RC to the power gamma minus 1.
-1.
Okay, in that you will be covering that the higher compression ratio of the CI engines, compression ratio is higher, and the thermal efficiency for the same amount of let us say same amount of power, you will be getting higher thermal efficiency. And the next question, SI engines are of lightweight, high speed, homogeneous charge of fuel and oil, all of the above.
All of the above, sir.
All of the above.
Yeah, it's correct,
All
because
of-
SI engine we have already covered. SI engines are not bulkier, so it is lightweight. It is lightweight, that is why they are faster. So, and also we provide homogeneous mixture of fuel and air. So the answer is all of them. So I think, okay, the compression ratio in a diesel engine is of the order.
Option D, sir.
14 to 20.
Option D, sir. 14 to 20.
Correct, very good,
After-
correct. Okay. Then the next question, main advantages of a 2-stroke over a 4-stroke. Okay, we have already covered that 4-stroke, we are getting higher power, we are getting. Then what is the advantage of 2-stroke?
More
Absence
power.
of valve.
All of the above, sir.
Okay, all of the above is one of the answer. Then
More power output for the cylinder. C. B.
Sir, absence of valve, sir.
D, sir. All of the above.
so answer is all of the above. So I will tell you how, because you see more uniform torque on the crankshaft. What does this mean?
Yeah.
Because in 4-stroke, if you see, there is one power stroke or one power stroke in 2 revolutions. So if you find the turning moment diagram, if you will do this one also, you will study in your kinematics and dynamic of machines. This is the turning moment, and this is the theta, the angle at which the crank is rotating. You will find that it will not be uniform in case of 4-stroke, but it will be uniform in case of 2-stroke, because there will be one power stroke in one revolution. So of course there will be more uniform torque in case of a 2-stroke engine. So this is correct. This one we have already discussed, more power output for the cylinder of same dimensions, then the absence of valves. This is correct, because in 2-stroke I have already told there are ports, there are not valves. So the answer is all of the above. So with this I think we have come to the end of the question answer session. So some of the questions I have already discussed, and I think with this you would be able to complete your assignment. So I think everyone might have completed their assignment, or they are still pending.
Pending, sir.
Okay, so I hope that through this it will be completed.
Yeah.
Sir.
Okay, so anyone wants to ask any question, or we'll close the session?
Sir, what is the minimum temperature inside the cylinder, sir?
Minimum temperature, we can say that maybe ambient temperature, or a little bit higher than the ambient temperature, because there in any case how much exhaust gases, although you will be sending all the gases outside the cylinder, but still there will be some amount of combusted gases which might increase the average temperature of the cylinder. So the minimum temperature is below ambient, it cannot go, because we are not cooling it by we are not cooling it by water or any chilled water or any other cooling substance. We are cooling it by air. Generally the automobile engines are cooled by air, so it will be minimum will be ambient. Okay,
Inside the engine.
inside the engine, yeah.
So what about we are doing combustion, all this?
What you asked, minimum, right? Combustion will increase the temperature.
Okay, okay, minimum. Right, sir.
Okay.
So maximum can go up to the.
Maximum, see, the maximum that we want to generally achieve is 280 degrees Celsius for, let us say, petrol engine. So petrol engine, if you are going to 280 degrees Celsius, there is combustion taking place. But after combustion, there some more amount of energy will be released due to the combustion, because the calorific value, the energy will be, the chemical energy will be getting converted, okay, to thermal energy. So the temperature might go up to, let us say, 400 degrees Celsius.
Okay, sir.
Okay.
So there is a we take actually the n by 2 and some constant value for finding the two-stroke and double-acting cylinder engine.
Correct.
Uh,
So, yeah. So I got your question. So actually, that we have already, one of the multiple choice question that I have already covered. So if you see the number of working strokes in a two-stroke engine is what, in one revolution we get one working stroke. Okay. So if n, let n is the revolution, in one revolution we get one stroke. That is why we don't divide by two. But in a four-stroke, in for two revolution we'll get one working stroke. That is why for each cycle the number of working stroke that we'll be getting is n by 2. Okay.
so for the two-stroke, it will be n by 2.
No. For four stroke it will be n by 2.
Four-stroke, it will be n by 2.
Yes.
And two-stroke, it will be n.
Yes.
So for the double-acting cylinders, then for that, how it will be?
Sorry.
A double-acting cylinder, double-acting, there will be single-acting and double-acting, isn't it?
So I cannot understand. Sorry, what you were saying?
So
Single
double-acting
acting or
cylinders.
double acting?
Oh, single acting. So in the single acting and double acting, there will one more factor will be multiplied. That is the number of cylinders. So this you are asking. See, there is the total formula. This also is there in the design parameters. What you are telling is the if you are calculating the indicated power or the brake power. So it is PLAN. So P is the mean effective pressure, L is the stroke, A is the area, and then N. N I am talking about the number of revolution of the crank for each power stroke. Then there comes the number of cylinder, or then comes the number of how many acting. If it is double acting, then you have to multiply 2. That is a separate factor. I am talking about when you asked whether it should be n by 2 or n. N I am talking about the revolution, not the double acting or single acting. When we will solve those numericals in the next live session. You will be clearly getting those doubt clear. Don't worry about it.
Okay, sir.
Any more questions?
Sir, diesel engine is heavy due to we want more compression ratio. Just this is the reason.
See, more compression ratio generates more pressure. So if pressure is higher, that means let us say if we'll make a thin cylinder or it will be lesser bulky. So then at a particular pressure it might get failed. Okay, that is why we make thicker valves in a diesel engine. Okay.
Okay, sir. But SI engine containing, sir, spark plug and that or carburetor, so it will not make petrol engine heavy.
No. Spark plug you might have seen. No, spark plug is is it too big? It will not make it heavy.
No, sir.
It will not make it heavy.
Yes.
See, the whole engine is, let us say, of stainless steel, and you just imagine the pressure that we are achieving at in any of this engine. It is very high. So the cylinder valves are very thick. The spark plug, they are just very spark plug valves. These are very less.
Okay, sir.
Okay. Okay, then we'll close the session for today. So what I will just summarize what we have covered. We started with the summary or brief summary of what are the things that we have already covered in this week lecture. Then we solved few MCQ questions. Then finally we had a discussion. So I hope you enjoyed the session, and see you in our next session. Thank you.
Thank you
Thank you,
so much, sir.
Thank you. Welcome.
Thank you, sir.